In this session, we will see the operations on linked list. We know we can perform different operations on linked list like traversal, insertion of a new node, deletion of a new node from existing linked list. We can sort the list, we can merge two linked list. So different types of operations can be performed on linked list. So we know a linked list is a list of connected nodes. So the first node is identified by a pointer called start. Then we have nodes like this, connected nodes or linked nodes. This is the diagram for a linked list. Suppose there are some values 10, 75, 20, 82, like that. So here the start node contains the address of the start pointer contains the address of the first node. So let it be 2000, which means the base address of this block, memory block or this node is 2000. And suppose this is 2300, which means here it contains 2300. That is the address of the node. The second node is stored here, the link part of the first node. And here this is the third node. Suppose it is at 2400, which means here contains 2400. That is the address of base address of third node is stored in the link part of the second node. And suppose this is 2600. So it means the link part of the third node contain the base address of the fourth node and so on. Now we want to perform a traversal operation. What is traversal? Visiting all the nodes or accessing all the nodes in the linked list is called traversal. Traversal means if we are moving through a list or an array or a data structure, if we are visiting all the elements or we are accessing all the elements or we are performing some operations on these elements, it is called traversal. Here, what are the steps to be followed for traversal purpose? See, what we have to do is we have to get the address of the first node. Then we have to access the data, then move to the next node, access this data, and it continues until the link part of a node becomes null. That is, it reaches the end of the list. So what is the first step? Step 1, get address of first node. And store it in a variable temp. So this will be create a pointer, get its address, get the address of the first node and store it in temp. So we can create a pointer called temp and collect the address of the first node. What is the address of the first node? 2000. Where it is kept? It is kept in the start pointer or header pointer. That this is a special pointer that always keeps the address of the first node. So it is available in start. we can write available in start. It's available in start. Then what is step 2? Access data part of node. Address in temp. Address of that particular node is kept in temp. So access the data part of the node. Using temp pointer. Then step 3, store link part of node. Again address in temp to temp. Then step 4, repeat steps 2 and 3 if temp is not null. So this is the algorithm, or these are the steps for performing traversal operation on a linked list. See, get the address of first node and store it in temp. So here we have the pointer temp. We are supposed to store the address of the first node in temp. So here we have the address is stored in start. So we can write a statement like this: temp equal to start, which means this points this. So here this contains 2000. Now access data part of node, that is address in temp, using temp pointer. How we can access this? Suppose we are going to print this, we can write a statement like this: cout temp arrow data. So that element is accessed. Any operation can be performed in this way. Then what is next step? Store the link part of node to temp. How we can do? The current node is this. We can write statement like this: temp equal to temp arrow link. So what happens? Temp arrow link. This is temp. This part is the link part of this current node now. So we want to store that part 2300 to this temp. So here it becomes 2300. What does it mean? This points this node, right? Then repeat steps 2 and 3. These two steps. If temp is not null, whether temp is null now? No. So what we have to do? Again access data part of the node. Cout temp dot data. So now it is 75. Then temp equal to temp arrow link. So it becomes 2400, which means this points this. Again temp dot data is temp arrow data is 20. That is accessed. And temp arrow link is 2600. Okay, 2600. Now it points this. Again access this element. Temp arrow data is now 82. And temp arrow link is null, it becomes null. So what does it mean? Repeat steps 2 and 3 if temp is not null. If it is null, that can be stopped. So this is the steps for performing traversal operation. So what would be the C++ code for this? We can write C++ code for this traversal operation like this. Say node star temp equal to start. So this term contain the start. Now while temp not equal to null, while temp not equal to null, cout temp arrow data. So that data part will be displayed. Temp equal to temp arrow link. So this is the code for traversal operation on linked list. Now the next operation is insertion operation. How to perform insertion operation? Insert operation in linked list. A new node is to be inserted. It can be here as the first node or the second node or third node or the last node. So we have to write a program or develop an algorithm according to that. How we can perform this? If it is the first node, see, usually we will traverse through the linked list to reach the particular position. Suppose we want to insert that position named POS. So it may be 1 or 2, 3, 4, 5, etc. We have to find out the nodes at POS plus 1 and POS minus 1. This is called the post node and this is called the pre node. We have to traverse through the linked list and identify the post node and pre node. Then only we can insert a new node. Suppose the position is 2. That means we want to insert a node at position 2. We want to insert a position at position 2. So this is the first position, this is second one, this is third, this is fourth. After insertion, this node is to be the second node. So in this case, position plus 1, that is post node, is here. This is POS plus 1 and this is POS minus 1. Now this position is the POS. So what we have to do is traverse through the linked list and find out the address of POS minus 1 and POS plus 1 and store this address in a pointer called pre-node and POS plus 1, that is post node, address of post node in post node, two pointer variables. So here this contains the address of node at POS minus 1, that is here it is 2000. This will contain the address 2300, right? Now we want to create a new node. How can we create a node? Say temp equal to new node. This will create a new node. So let it be created like this. It is, say something like this, and its address is there in temp. So let it be 4000 say some 4000. So the starting address of this is base address of this newly created node is 4000. Now we want to insert data, temp arrow data say equal to 100. That value is inserted. So this contain 100. Now temp arrow link equal to null. Let it be null. So a new node is created. Now what we have to do is we have to connect the link part of the POS minus 1 should be this temp, and link part of this temp should be this post node. So how we can do that? See, we can write statement like this. So this is, we created a node. Now we are going to insert this in between at position 2. So here in pre-node we have the address of node at POS minus 1. In post node we have the address of node at POS plus 1. Now we have to do, what we have to do is we have to link the address part of, make the address part of POS minus 1 with the address of temp. So we can write like this. Pre-node link equal to temp. What happens now? Pre-node arrow link equal to temp. This is the pre-node. Pre-node arrow link, that is this part is temp. That is, this becomes 4000. What does it mean? This indicates this. Right? Now the next one is we have to store the address part of this with this 2300. So we can write temp arrow link equal to post node. So what happens? Post node is 2300, which means this points this. So we have inserted a new node at position 2. So this is the algorithm for insertion. If it is at the end node, you traverse till the end and it is easy to connect. And if it is the first node, you will create a node and it will be the address part of that node will be the start, and the address of the newly created node will be inserted in start. So how we can write the algorithm for this? We can write the algorithm. So in order to perform insert operation, step 1 is create a new node and store its address in temp. Step 2, store value to the node using temp pointer. Step 3, traverse through the linked list to get address of nodes at POS plus 1 and POS minus 1 so traverse through the linked list to get address of nodes at POS plus 1 and POS minus 1. POS is the position where we want to insert the node. We want to insert at POS. So we have the address of POS node at POS plus 1 in post node and address of pre-node, that is POS minus 1 and in the pointer pre-node. Now step 4. Store address of the newly created node, that is temp, to the link part of node at POS minus 1, that is pre-node dot link equal to temp. We can write a statement like this. Then step 5, store link part of the newly created node with address of node at POS plus 1, that is post node. So we can write a statement like this: temp arrow link equal to post node. So these are the steps to insert a new node into a linked list. Delete operation. So we have a linked list like this. Start. So this be the linked list. Now suppose we want to delete a node at POS. We want to delete this node. What we have to do is traverse through the linked list and identify the nodes at POS minus 1 and POS plus 1. So this will be stored in pre-node, and here we have post node. 2 pointers, pre-node and post node. Pre-node contain the address of this node at POS minus 1, and here post node contain the address of node at POS plus 1. Now we want to delete this. So what are the steps to be done? We have to store the address, that is address stored in post node, into the link part of the node at POS minus 1. So what are the steps? Step 1, traverse through linked list. 2, locate node at POS minus 1 and POS plus 1 and store address of these nodes in pre-node and post-node respectively. So we will get the address of node at POS minus 1 and that at POS plus 1 in pre-node and post-node respectively. Then what is step 2? We want to store the link part of pre-node with the address of node at POS plus 1. So store address of node at POS plus 1 to the link part of node at POS minus 1, that is pre-node arrow link equal to post node. What happens now? Now this address of this, suppose this is 4000, this 4000 will be stored here. So this will be, here it will be disconnected and this will be made something like this. Now suppose we have stored the address of this in temp, that is node at POS. Step 3, delete node at POS. We can write delete temp or something like this. So this is the steps for delete operation, deletion of a node from linked list. So we have to rearrange the steps if it is the first node or if it is last node to be deleted, and logic can be changed accordingly. So these are all about linked list.